Hello, my name is Jamie, and today we're going to be talking about irregular grids. An irregular grid is effectively taking a larger shape and breaking it up into a series of smaller shapes that are randomly assigned. So, drawing inspiration from this blog post and algorithm for irregular grids, I added an irregular grid implementation to cadqueryhelper, which is a library that I wrote. Let's check out the article. So here we see some examples we get some definition, and we start seeing some examples of grids that have randomness applied to them. So, and here's some further examples. This is a great article. Read through it, delve into it. Basically, I took the concepts from this article and applied them to CadQuery and wrote an irregular grid implementation. Uh, yeah, here we start getting into the gist of it. A lot of what he does is basically we define a grid, we start defining out a Boolean truth table effectively for the collision map, and we start assigning rectangles to this grid and then testing if the space is already filled and then assigning a new rectangle. Yeah, starts getting into that. Yeah, there we go. So we get into a Boolean grid, or I call it a Boolean matrix, either way. How to start packing it. In this case, he's using for loops. In my case, I'm using a when loop. Yeah. Yeah, this is good stuff. This particular pass is when it starts getting weird for what I'm doing. I'm doing different stuff when it comes to this. So check out that blog article, and I'll have this link in the video description. Now I'm going to start getting into basically how to implement one of these guys in CadQuery, particularly using CQ Editor. So some helpful videos is if you don't have CadQuery installed, this is how to do it. So we've got a video and a script. If you're looking for tips on how to install CQ Editor, here's a video for that. And then the code I'm using is checked into cadqueryhelper, particularly this regular grid code. There's documentation for it. Here's documentation for the irregular grid code. And then here's the raw code itself, if you want to start going over that. And then the last example I have uses CQ industry, which is basically these walkways, right? These walkways. These are all using irregular grids. So I have an example directly using it for this first walkway. First, we're going to define the overall shape of your grid in length, width, and height. So we're going to define the length and the width and the overall height of the area that we're going to take up with our grid. Then we define the individual cell size in millimeters. So here we have the call size and the column size and the row size. And these are both, for this example, 5 millimeters. So we have a grid that's about, let's see, one, two, what does that end up being? It's like 75 by maybe 50, I think. So 75 millimeters by 50 millimeters with a call size of 5 and 5. Next, we define the number of cells in columns and rows that an item can take up. When we start talking about how we're going to fill this grid, the 5 by 5 cell is our smallest unit of measure. We basically take a larger grid and break it down into a smaller unit as far as managing with the collision map. We define the max number of rows and columns that a given item can take up. So in this particular cell right here, this purple area has a max columns of 1 and a max rows of 1. So every time we rolled an entry, it would only be able to take up one cell. In this example, we're showing another cell that has a max columns of 3 and a max rows of 2. So every time we do a roll, a cell could take up one space, it could take up 2 by 2, or it could take up, 3 by 2, right? And those are, and 1 by 2 would be accessible as well. Those are the shapes that we can come up with in order to fill this space effectively. And this sets up the outline of the grid when we randomize, and then we randomize a bunch of stuff. How we're doing the randomization is we're setting a seed string, a value for a pseudo-random number generation. And what that means is that when you write your script, by applying a seed, these results can be repeated. It's not complete, it's not straight noise. It's not based on, the timestamp, month, day, year. So normally when you start a random generator, it's generated by some sort of timestamp, and then any preceding numbers are derived off of that, right? In this case, we're applying a seed so that when we generate results, the results are predictable every time to an extent. Start adding more roles and things get a little wacky pretty quick. We're also going to tell the grid the max height an item can be. So specifically, this is for managing items laid out in a 2D plane. The height is also being randomly rolled, but it's not doing the same packing mechanism, right? The height is also being randomly rolled in order to get this irregular pattern going across. The developer, so the person who's implementing this, is going to provide a callback method that takes a length, width, height as parameters, and it returns a CadQuery shape center aligned by all three axes. So basically, if you provide if you provide the grid a method that takes these three parameters, length, width, and height, and return back a shape, I'll put it into the grid in its corresponding space. The code takes your custom defined shape and places it on the grid. Yeah. We use a Boolean matrix matching the rows and columns of the grid. Boolean matrix matching the rows and columns of the grid is updated to reflect the space now reserved. Oh, okay. Yeah, that's a little bit wordy. But effectively, so for each of these cells, we have a Boolean table that is filled in with, I think, let's see, what are they filled in? Okay, so they all start off as true, which means that the cells are available. And then as we fill them in, the cells are marked as false. They're no longer available for placing objects into. All right, so now we get into the examples of the Boolean table. So in this case, if we have a grid that's 10 columns and 5 rows, and we add an item that's 4 columns by 3 rows, it will be represented on the Boolean matrix as such. Here's our total, here's our grid. So we take one of these guys, we roll it into a Boolean table, and in this case, we have got an object that takes up 4 columns, 1, 2, 3, 4, and 3 rows, 1, 2, 3. We yoink all those cells where the object is going to be written, and to this table, we change it from true to false, which is going to reserve this space. All right. Then the grid finds the next open position, which is the fifth column and first row, or in this example, column E and row O. We're going to say this is our next open position, so we're going to roll our next shape and then fill that in to the corresponding rows and columns based on its dimensions. So roll the next item's dimensions. By random chance, it happens to be 2 columns by 4 rows, which gets placed on the grid. And it'll look something like this, right? So here's our first object, here's our second object, and here are the space reserved for these objects. So far we have this, and it'll look something like here's our 2 rectangles. And then if we continue the process, we'll find the next open position, which I'm going from top left to right when looking for open positions. I suppose the algorithm could be changed in order to start at a different location, but for this implementation, that's what it does. It starts in the top cell, so 0 by 0, and then it scans across looking for the next open position. Because you can get these irregularities like, this row is already partially filled, right? So you'd have to, when filling this in, you'd start here, start filling in cells, you'd come across here, you'd hit a false here and jump over to like column G effectively. All right, continuing on, we find the next open position and repeat the process until the grid is full. So here are our 2 cells. Started here, rolled a 1 by 1, started here, rolled a 1 by 5, started here, rolled a 1 by 3, one by one. And then we go over to the next row, scan across. Here's a 1 by 4 that was rolled. Skip, skip, 1 by 2, thereabouts. Yeah. Start up at the next open row. This is all filled in space. Next row, this is open 1 by 1, was rolled 1 by 1. And then here we rolled a 2 by 2. And we just continue on the process until the entire space is filled in. Or we hit our max number of code passes. So because this runs in a loop without an ending condition, right? If the space is not totally filled, it could potentially run forever. So you can set an arbitrary hard pass limit for how many iterations you're allowing this thing to do if it can't, if it's unable to fill the cell entirely. The code, in order to build this shape, looks like this. And why don't we just start it up and I'll show you. So I'll go to CQ editor. I'm going to go to my virtual environment. We're going to run CQ editor. Okay. I start a new file. We'll do a save just so I have it, because I may end up referring to this in the video. Scribbles. Yeah, I kind of like that. I already started one, but we'll do a second one. A regular grid demo too. Sure. All right. So we're going to import in CadQuery as CQ. Well, from CadQuery helper import irregular grid. And again, so this is part of a library that I wrote. You can check out the code and the documentation. At CadQuery helper. Yeah, this page, this repo. Okay, so we've got CadQuery helper, import irregular grid, and helps if I spell it right, that kind of stuff. And then we'll do a basic implementation. Doesn't matter. No, you have starters. Let's see, we'll say IG equals regular grid, and then we'll do a show object. IG. Sure. Save that. View it. Bam. And you can't see anything. It just looks like one space. Hang on a moment. We'll add a parameter. I think it's union grid. Let's verify. What's the parameter I'm looking for? Union grid. You're at. We're going to say union grid equals false. Maybe. Capital F. There we go. Okay. There's our first initial starter grid. Nothing set to it yet. I did the union grid because what it's doing is, in this case, this is adding the shapes to the plane, where if I union them, it'll basically merge them together into one shape. And then, because this is a flat grid, it doesn't have a max height yet. Differing from the regular height. We'll say 10. Because it doesn't have a max height set, they were all limited to a height of 2. Right, so if I say height is 2, let's do 3. Why not? And a house if I put my commas in. There we go. Cool. Neat stuff. So now I can do the union can be true. And we'll show you. So that's you see here, these aren't individual shapes anymore. These are now joined together. So by default, the irregular grid does a union operation. To speed it up, you can set it to an add operation, so set that to false. That'll also make this process run quicker, and you can see the individual entities as shapes. Okay, so let's go back to our example right here. So, in order to remake this shape, I'm going to grab this code right here. And we'll call this a regular grid, and we'll talk about that in a moment. Comment that out. Run this guy. Okay. And here's our example grid that we have in the documentation. So here's the starting cells, and then here's the rest of the fill material. And I'm being particular about those starting cells. So you see here I'm defining the fill cells. So if I take that out, this is what the grid looks like when it's completely random. And this is what the grid looks like when I hard code two of the cells. So in this case, I'm setting at starting position 0, 0, fill in with an entity that's 4 columns by 3 rows, and then at starting position number 4, fill in row 0, fill in with an entity that's 2 columns by 4 rows. So I'm hard coding two of the cells, interesting feature. And then the rest of it's being filled in by this seed. So if we change the seed to like test2, our shape should, in theory, change. Yeah, that's different. So here we're setting a length of 100 millimeters, length of 100 millimeters, a width of 50 millimeters. Our col size is 10 by 10. So each column, and do I have max rows? I can show that real quick. Hang on. Yeah, okay. So max columns equals 1, and max rows equals 1. Our comma in there. I can show that, I think. And we need that union grid. So because we're doing the add operation, they're getting union together. Okay. Does that work? Only if you do your commas. There we go. So here's our starting grid. So our max columns is 1 and our max rows is 1, which just makes an arbitrary square grid, right? So it's, and then our col size and our row size is 10 by 10. Now we could change that. We could change it to 20. And see, now we cut down our rows and columns. So we define our shape. We define our overlay grid on top of that shape, and then we start breaking it up randomly um, by rolling out items using a seed. That's the gist. All right, so pull that back, and that should all work. And if I go back to test 3, and of course I broke something, this guy. Neat. Oh, that's wicked cool. I didn't realize that this could override that rule. Well, that's cool. So you could set starting items that are bigger than the actual allowed randomly rolled items. That's neat. Cool. Yeah, so that demonstrates the idea really well. Effectively, here we have our first cell that's, hard-coded set. Our second cell, it's hard-coded set. If we set third cell, where would we go? We would go to, we're starting at 4, what is that, 5, 6, we'd start at 7, I think, and 1, and we could do, uh, let's say 4 by 1. Does that work? Out of range. Set you back to 6. See if I'm off. Yeah, I was off my key by 1. Okay. Yeah, there we go. So cell 1, cell 2, cell 3. And so here I'm not doing it random at all, but that's how the packing mechanism basically fills in. Is so we find an open position, we roll some random stuff, we start putting it in the grid, and then we check against the truth map to see if it can fit in that allotted space. Neat. That's cool. All right. So yeah, heads up, I'm cheating by setting the first two items to match our specific dimensions. The rest of the cells are randomly filled by the seed. Test 3. How simple is that? Yeah, wicked cool. Neat stuff. And now we'll start getting into some further examples. All right, so here's a simple implementation. And how do I want to show this guy? Do I want to just keep this here? Yeah, maybe. Keep it rolling. Or do I just override it? Good question. Let's go here. So let's grab it. And we'll talk about what I'm doing. It's a different name anyways. Okay. This might get a little slow because I'm dumping these on top of each other. But that's okay. So we're going to make an irregular grid. It's going to have a length of 75, a width of 50, a max starting height of 2 millimeters, a max height of 10. That's where we get the height variations. Call size of 5, row size of 5, union grid of false, and we're going to use the seed test. Yeah, there we go. So what this is showing is the variable height. And there is actually a height align key too. Let's go here. What is it? Passes count, seed, make item, align Z. There's an attribute called align Z, which equals, we're going to set to true. I'll show you what that looks like. So now everything is, so the Z-axis on the output is centered at the 0 point, and then these items just match whatever they were rolled up to. Okay. There was another attribute I wanted to talk about too while I was looking at this. Passes count. That's the other one. This one's worth talking about. We'll say passes count equals 1. What this does is effectively, if this is set to none, this will always run until the entire space is filled up. So when passes count is set to none, the truth table here, this truth table will always be filled up. With a pass count, you can set how many iterations this is allowed to run for. So if we set this to 1, it fills in the first cell, 2, second cell, 3, assuming I have it running correctly. It didn't find anything on the third pass. Fourth pass. Nope. Fifth pass. This is going to get a little boring. There we go. So it took 7 passes before it was able to roll an item that could fill into this space. Um, and so for particularly larger grids, if you start hitting performance issues, you may want to limit the number of passes, right? Or optimize the code further. We get into that. Right now it's sub-optimized in regards that it could run for uh, a fairly long execution time, right? It's not particularly performant at the moment. So if say we set this to 20, there we go. So we haven't entirely filled the space yet. And if we check with another flag on here, when we're troubleshooting this guy, there's one called Union Grid, include outline. We'll say equals to true. That's a feature flag. And house if I use my commas. Okay, so this is the space we're trying to fill. And in 20 passes, this is how many objects we got. So we got 1, 2, 3, 4 objects. If we define this to say 30, nope. And if this code was smart, what it would do is it'd see, because it's starting this starting position, and it's not going to go further until it rolls something with a call size of 1 that can fit into this space that's less than call size of what? 1, 2, 3, 4, like 4, basically. Let's do 50. Helps if I type it out right. There we go. So in 50 passes, it was able to roll something that could fit in this space. And I bet in 51, hey, we got lucky. On 51, it was able to find an item that fit in this space. Yeah, cool. Neat. All right, so we're showing randomized height. Now we'll show setting a custom callback. This is I grade 2. Oh, cool. I can just copy this in here. Dig it. And we'll comment you out. There we go. Control S. All right. So what this one is we're basically defining a grid that has a length of 150, width of 50, height of 2, max height of 10, and then call size of 5, row size of 5, a line along the z-axis, which we've already talked about. We're going to include our outline. That's cool. We've already talked about that too. We're going to set our seed to test, and then the new thing that I'm adding is custom item. Custom item is a callback method, which we've defined up here. We're going to, this is going to receive, when invoked, it's going to receive length, width, and height. We're going to return back a CQ CAD query shape. So we're going to define our work plane along the X and Y axes. We're going to make a box. In this case, I'm basically using -1 as a padding, a margin between cells, so between the shapes. So we'll fill up to this size of the allotted space -1 millimeter on each side for the length and the width. We'll use the height as described, and we're going to apply a chamfer of 0.5, which is basically going to cut the corners. All right, let's try it. Save it first, and we'll try it. There we go. This wasn't slow because of the algorithm in place. So we'll see it running with another example where it runs fairly quickly. This was slow because of all the chamfer operations. For whatever reason, chamfers are fairly heavy in CadQuery when it applies them. So for doing all these individual shapes that were then chamfered and then dumped out really quick, um, it got slow. Relatively slow. Depends on your definition. Um, And this is where the max rows and the max calls comes into play. So because this is 150, potentially, like on a really bad roll, you could roll an individual item that takes up the whole plane, right? Max number of columns. So by default, if max calls and max rows is not set, then it can roll up to the entire width or the entire height of the plate. So if we set max columns. I think that's what it is. Am I doing that with any of these? Yeah, max columns. So if we set max columns equal to, let's say, 5, then this huge plate right here, this large piece right here, can only be rolled up to a max of 5 columns. All right, save that, roll it. Good. There we go. Hey, it took. Nice. And then if we set max rows, then it couldn't take up the entire space. Right. Neat stuff. All right, we'll go to the next example, which is my skyline example. Here I have the number of passes limited, just for visual effects. I didn't want to fill in the entire plate. And we'll grab our stuff. I don't think custom item changes in this case. So we'll say grid 4. And so understand, by just commenting out these show objects, I'm still running them, right? It's still making the object, so that's not helping my performance either. All right, because I'm basically doing wasted work without showing it. So let's see if I can help this out a little bit, because this is the one that was performing the worst. Yeah. Okay. So here we're going to set a length of 100, width of 100, height, call size. So we got a max call size, a max row size. Um, oh, these are different. So, okay, that's cool. So we're changing the number of columns and the number of rows. That's cool. They're independent of each other. That's neat to show. We're setting our max columns and our max rows to 4 and 4. Max height is 50, so fairly high. Line along the z-axis, so it's zeroed out. We're going to include our outline, union the grid to true. Oh, that's cool. I might set that to false. Passes count 160, seed is purple, and we're going to use our custom make item. All right, save that, run it. There we go. Cool. And I'm curious if this will run faster if I say union grid false. So what it's doing is these are all being joined to the outline, the template here, the initial size plate there. If I say union grid is false, run it, does that run any quicker? Yeah, a little quicker. Yeah, that ran a bit quicker. So yeah, the chamfers might not have been the culprit in this example. Let's go back. I bet they weren't. I bet it was the union. Bear with me a moment, because I bet you ran fine. Okay, translate. What do I want it by? 0 by 0 by 0. We'll say 200 in the positive. We'll say negative. Width, that'll do it that way. You'll try it. Oh, you're still doing the union. Oh, I don't need that high. Too aggressive. Where's union grid? There we go. Okay. Disregard my assertions about speed. It was the unioning. So the chamfer wasn't the culprit in this case, it was the union. Yep, I was mistaken. Union's important because effectively, if you don't want to have a large number of multiple shapes kind of all stacked on top of each other, the union will join them into one shape. But in order to do those intersections, and in order to do that, it's making a performance hit, throwing a lot of small shapes onto a larger shape. Fluid outline. Yeah, I'll play with that for right now. Okay. And then as you see, this guy is I'm limiting the number of passes down in order to not fill the entire plate. We'll save this. And so in this case, I'm taking the flag out, so it will fill the entire plate. In this case, I didn't like the result. That wasn't as that didn't achieve the desired effect I was looking for. So I limited the number of passes. There we go. Okay, cool. Save this guy. And then I think we get into the final example. Okay. So applying irregular grids to terrain. So in this case, this is actually applied. For me, this is the payoff because I can do complex greebling in a relatively straightforward fashion. Um, Greebling is just filling white space with detail, effectively. It's a term that you see a lot used with like Star Wars or any kind of terrain. So it doesn't serve any functional purpose, but it adds something for the eye, so visual, right? So here we have a walkway. We're setting on a regular grid, and in this case, the irregular grid is made up of a series of tiles, effectively. And here is the code for that. Copy you. Do I keep this all here? Maybe. Just to show you an example. Show you that they play nicely together. So you're importing random. All right, let's change our imports. So first off, just to prove it out to you, start a new one, paste our code, run it. Cool, there it is. Um, but we can also show it in line with the other stuff, which is kind of what I want to do because I think that'll help more as opposed to just throwing a bunch of new code at you. Um, Regular grid demo too. Yeah, this guy. Let's get back here. So what am I doing? I'm importing in random because we're gonna roll our own random stuff for the tiles. CQ industry, we're gonna pull in. Oh, cool. Okay, these are just different. Okay, that's fine. CadQuery helper for the irregular grid. Bam. So we're pulling in CQ industry for its walkway code and CQ terrain for its tile code. Um, okay. And then we're going to define our tile styles. Let's go down here. We're going to define our tile styles. So we're going to pull in, let's show you GitHub. What is it? CQ terrain. Yeah. So we'll go to this tile code. So we're going to pull in these things. These are individual tiles made in a repository I made called CQ terrain. And so we're going to pull in the plane tile, which I think is right here. We're going to pull in the chamfer frame, should be up higher. This one, I don't need to see it. Yeah, okay. We're going to pull in the rivet, somewhere right here. And we're going to pull in the slot, which should be further down. This guy. All right, so these are basically shape primitives pulled in from this library, but you can define your own tiles as long as it takes the three parameters, length, width, and height, remember on the callback. As long as it takes your parameters and you can build it, then you can use any arbitrary shapes. All right, I have this thing called the style count, which is basically just the length of our array of tiles, accessible tiles. Let's go back to here. Now we've got our custom tile, which you can name that method literally anything. You're just assigning it to the regular table, right? So here we go. This guy is going to take a length, a width, a height. We're going to set our tile style to a randomly rolled range, basically against this array. So between 0 and the length of our array, we're going to roll a number. That's going to be our index in order to retrieve off of this array. So we're going to say our tile equals tile style, and then this given number, so 0 through 6, 0 through, what is it? 0, 1, 2, 3. So 0 through 3 is what's going to be rolled here, right? We're going to get a random number. We're going to apply the length, width, and height to that. Easy peasy. Okay, we'll get back our tile. We're going to return that. So this will be a CQ work plane dot whatever when we get that back. Then we have the definition of a walkway. I can just grab all this code. So walkway has built-in support for the irregular grid. It has a number of other uh, render modes as well. Okay, so walkway is a class object, so it has two life cycles. It has a build and a make life cycle. So here we're setting the length of the walkway, the width of the walkway, the height of it, the chamfer at the bottom cut, the undercut of the walkway. We're going to tell it that the render mode, which I need to change that parameter, but it'll work for today. The render mode is irregular, which is our regular grid. We're going to set, now we get into the parameters you recognize, so we're going to set our max height, our seed, in this case OR. Our make tile method is a custom method right here, so that's our callback. We're going to say our max columns is 5 and our max rows is 5. Those still all apply. Because the length and the width that are passed into this method are determined beforehand by this max columns and rows. Okay, we're going to do render tabs. All this other stuff is lifecycle stuff for the rest of the walkway. They're not regarding the regular grid. Okay, we're going to render our rails, render our rail slots. Yeah, that's fair. Yes. Okay. We're going to do a make, which is the build life cycle. Yeah, well, it's the make life cycle. And then we're going to do a build on this, which will generate off the finalized component. And then we'll do our show object, which is walkway small. And I'm going to do a translate on that. We're going to move this. Translate 0 by 0 by 0. And where's the other one going? You're going at 100. We'll do minus 200, so I know they don't collide. I hope they don't collide. Save that. Okay, run it. See what happens. Okay, cool. And the whole purpose of this is to, one, break down what this code is, and then two, show you that I'm not joshing you. They all can live, happily together, right? We're not doing any weird demo shenanigans. Okay, save that, refresh it. These are all compatible libraries, effectively, is what I'm trying to illustrate. I don't need it that it's close. Bam. Okay. So here we see our tile styles, we see all that, and if we want to start modifying it, let's take out slot terrain, slot tile. Boom. Save that. And now this tile is no longer in the pool of available tiles that we can use, right? Because we commented it out. And we can add other tiles in there as long as it takes the width, length, and height, right? Do I want to do that? Not right now. Okay, that's enough for the demo. That's enough to wrap your head around. So this is still applying the irregular grid. It's just not only with boxes, but also with a subset of randomized greebles, effectively. And we could not randomize it. That would be fine too. Doesn't have to be randomized. Now the only available tile is rivet, so every time it rolls, it's only going to roll rivet. I don't need all this random roller shenanigans, but it's cute. It looks like it's using rivet and plane. It's kind of what it looks like it's using still. I'm not entirely sure why it's doing that one. Maybe height, could be a bug. Yeah, that's almost veering into maybe it's a bug territory. Don't know. Just hard code you. What does that do? Breaking stuff now. We're getting into my curiosity. So here we're going to get our custom tile. We're only going to say custom tile dot rivet. We say length, width, and height. Return our tile. What do you do? Same thing? Do you still break? Yeah, kind of. You still break. Those ones don't have it. It's the height. I bet you it's the height. Oh, I have some hard-coded limit on how tall these things are, I bet. That's what's going on. Where's the height? Where's the max height? Not you. Max height on you. This guy. What if we just set it to 2? Yeah, there we go. So I have a bug. There's a hard-coded limit to how tall the rivet, the cylinders cutting through here for these rivets are. It's basically going through the cross section, right? So if I set this to 4, they all disappear, and we don't have to set it there. We say tile height. Yes. So I bet if I set tile height to 4, we'll leave that at 4. Yep, they all disappear. I have a bug. Look at that. Isn't that cool? Neat. Great. Um, but yeah, so irregular grids, they're cool. And I'm going to start using them all over the place, effectively. And what I wanted to do is basically show, one, that you can do this with CadQuery, start applying these generative coding concepts, right? And you can do neat stuff, really cool stuff. So, anyways, this was a whole other topic of discussion that I delved into. While you're here, also check out CQ Industry, CQ Terrain, the terrain tiles, which we just looked at, and then this entry for the Mini for All walkways. This guy. Okay. That is enough about regular grids. If you made it through this, thank you for watching. I appreciate it.